Welcome to this Montgomery Amateur Radio Club video, D-Star 101, presented by Bruce WA3SWJ. D-Star is short for Digital Smart Technologies for Amateur Radio and holds particular promise for first responders during emergency operations when they need to transmit emails, documents, images, and spreadsheets in the event that the internet goes down. So this presentation will summarize D-Star technology and operations and will update club members on the status of our D-Star repeater.
Okay, so what it is, what can I do with it? We'll talk about the repeater gateway system. That's sort of the secret sauce of this thing. We'll talk about some of the equipment, the user equipment, and the importance of registration. We'll talk about, and we'll talk about your first call. You know, that you've heard about the 4 call signs with D-Star. And we'll talk some about routing, and then there's just sort of some discussion questions. You know, it's not that not everything's a great. There's some downsides. Okay, so let's talk about what it is first. So Wikipedia. D-Star, Digital Smart Technologies for Amateur Radio. It came out of Japan. An icon was around. They sort of donated all the equipment initially for all the initial testing, so no surprise that they're there. D-Star is an open protocol. I think some of the early comments about D-Star is a proprietary, it's ICOM only, and it's really not. We'll talk about that in a minute. It is an open protocol. There's an on-air, what they call an airlink protocol, which is the portion between radios. That's documented and published. There's another part, the gateway portion of the protocol. That's the internet part of all the protocol, and that's all published. The thing that is, and I won't call it proprietary, but there's a specific little chip in here called an AMBI chip, Advanced Multiband Excitation, from Digital Voice Systems, that does some of the secret sauce. Basically, you're taking sampled audio data and converting it to a much lower bandwidth serial stream to go out over the air, and there's some magic there. It's proprietary, so you have to buy the chip. I went out to try to look on Moser Electronics to see how much the chip costs, but apparently you have to be an OEM, so I couldn't find a price. But essentially, they take a voice, our voice that's sampled at some high rate, and convert it down to a 3.6 kilobits per second. I did also see out there when I was poking around that they did just announce, or recently announced, that they've got some software now, so you don't have to buy the chip. So I think we'll start seeing some interesting new devices there. So you can buy some software that does what the chip does, but you will have to license it, license the software from them. Okay, so this is our typical analog AM/FM FM transmitter. And basically what it does, it takes in the microphone, goes into an audio amplifier, some audio conditioning. It mixed with a local oscillator and a balance modulator, and you've got a frequency modulated signal, and you mix that with another signal, so you get your on-air frequency, you amplify that and shoot it out. That's the basic block diagram of an analog transmitter. So what does a D-Star radio look like? So in a D-Star radio, here's our person talking here. I'm going to take my voice, I'm going to convert it to just a simple analog to digital conversion. They're going to put it into this chip, and this is where the magic happens. It's taking the samples here, parallel 8 or 16-bit samples. I forgot to look that up, whether it's 8 or 16-bit samples, I don't know how many per second, and converting it into this serial bit stream. There's a controller in your radio that essentially it takes the data from this chip, takes the data from a serial, puts some header, essentially builds a frame with a header and data slots, and makes a serial frame and feeds that to a modem. And then that's what gets put out on the air. So we've got those steps there. So let's take a drill into each one of these a second. So here's the AMBI chip down here. So here's our assembly line up here. So this is the AMBI chip right here, this piece. And so you can see, and again, I learned some things. It's always fascinating. If you want to learn something, you have to talk. A good exercise is to talk about it. So I didn't realize, I thought we were feeding the analog signal into the chip itself, but we're not. The vendor who's ever building the D-Star equipment has to do the initial analog to digital conversion, do the samples, take the analog signal and convert it to a series of digital samples. It's that series of digital samples that we feed into the chip. Okay, and then the chip adds its own forward error correction, does their secret sauce in there, and puts out this serial bit stream. And so this brown box over the communications link channel is the rest of these boxes, the controller, the modem, and the RF link. So these three are represented there. There's the chip. And there's the initial kind of analog to digital conversion. Everyone okay so far?
Just a quick question.
Sure.
So, but the radio portion at the far end,
yes,
that's still like the traditional analog stuff that was on the previous block diagram, right?
Yes.
Because it's still seeing like an audible signal.
Yes, this part's still the same.
Okay.
It
Yes.
still sees a GMSK audio stream.
Well, this is GFK, but yes, it looks like an audio, it's an analog signal.
Sounds, oh,
Yes. You can sort of hear 1200, right?
right.
You can't hear 96 and 48, you sort of hear it's like background noise.
Yeah, yeah.
Okay, so let me just introduce two pieces of terminology initially here. There's something called digital voice, DV, and that's this 3.6 kilobit per second data stream. It's got 2.4 kilobits per second of voice and 1200 bits per second of FEC, forward error correction data in it. And there's also within this thing, they also include a 1200 bit per second data frames, so you can add text messages or other data. We'll talk about this more. But it ends up being about 6.2 kilohertz bandwidth using GMSK. We'll talk about what that is. And there's also DD, so DV and DD. DD is what they call digital data. Right now it only runs on 23 centimeters, 1.2 gigahertz, and there's a radio for it, but they call that DD. We'll talk about that. Okay, I just want to introduce DV and DD. Okay, so here the controller, that was the next box in the assembly line. So this is assembling this frame down here is the work of the controller. It generates a header on there, it's sync characters, sync bits. It gets some header information, call signs and stuff, builds a header. This is the AMBI chip again. It takes the data samples from the AMBI, the serial data from the AMBI chip, and then interspersed between the voice data is this digital data that either comes from it repeats the header. There's a text message you can put in here. You could put GPS data, lat long data could also go in there, or data coming in from the port on the radio. So that also has to get put in there, and then there's a trail bit. The TAPR guys did a much nicer picture. Again, this is the DV protocol. This is the on-air protocol. This is the protocol between receivers, transmitters and radio. So this is all published, all common knowledge. So there's a header and a data section. The header, this is the expansion of the header. The header's got a bunch of bit synchronization flags. It's got a radio ID here and a frame check sequence. The radio ID then consists of these call signs, right? Destination call signs are all in there. This was new news that you could put a little 4 characters on the end of a call sign, and that shows up there. I didn't know that. So it's new too. The data section here, again, when I talked about it, this interleaved collection of the audio frames, data frame, audio frame, data frame, audio frame, data frame. It wasn't clear in the spec if this is one. You hold the push to talk down, and this will go on as long as you hold the push to talk down and are talking, and then when you release it, that ends it. Or if there's some max number of frames in here that have to get cut off and it starts another one. I couldn't find that. I'm sure it's in there. I just couldn't find it. So this is the common air protocol. And again, in the spec, you can go read it. It's all out there. They're all, what the bit pattern is for frame syncs, sync flags, terminating flags. It's all spelled out there. Yes, sir.
So is it UDP or TCP as far as the way that it's, is there handshaking or is it just send and forget?
I'll get to that.
Okay.
We haven't gotten that far yet. But yeah, hold that question. Okay, so far we've encoded it, we've got the controllers assembled these frames, and now let's go look at the modem, the GMSK modem. Anyone knows what GMSK stands for? I didn't either. I had to look it up.
It's Gaussian shift key.
Very good. That's good. So back to Wikipedia again. So I read this, it was very interesting. Here's a Gaussian distribution here, and I couldn't get my head around, been out of school for too long, sending this series of bits into a Gaussian filter. But you can read this, and they talk about how the Gaussian filter increases the modulation memory in the system and causes intersymbol interference, making it more difficult to differentiate between different transmitted data values and requiring more complex channel equalization algorithms such as adaptive equalizer of the receiver. The net is, I think the most important sense is, GMSK has a high spectral efficiency, but it needs a higher power level than QPSK, for instance, in order to reliably transmit the same amount of data. And so that's something I think everyone will notice and tell you about D-Star compared to analog FM. On analog FM, and I think we see it demonstrated on Sunday nights, someone can be very scratchy and noisy, and Fred's able to pick them up and hear them and say, oh, I recognize, I can't hear all what you're saying, but I got the gist of it, recognize the name. So our brain and our ear do a great job pulling information out of that FM, can be a noise signal. With D-Star, it either decodes or it doesn't. And in order for it to decode, it needs a sort of higher power level, and this sort of explains it. So it's a very efficient in the spectrum, but you pay a little bit of price for that. So D-Star is not a good weak signal kind of medium to do stuff. And you'll hear, I don't know if everyone heard the expression R2-D2. If it doesn't decode, you'll hear what sounds like the space, the little robot on the, what was that?
Star Wars.
Star Wars, thank you. I don't know why, another one of my plaguing questions with D-Star, why it knows that the frame check sequence didn't match or got in CRC error, why it doesn't just automatically silence the frame and throw it away, but instead you hear it. I don't know why they do that. It's another one of my mysteries. But this sort of explained the higher power levels of that's needed there. I thought it was kind of interesting. Yeah. The other thing I thought was kind of interesting too, they talked about this continuous phase frequency shift. The other trick they've done, they've noticed when another shift modulation techniques, they'll just change from a 0 to 1 anytime during the cycle, the phase cycle. So you'll get these discontinuities, and apparently that generates a lot of spurious sidebands. So if you change the data values at the 0 crossing, then you have what they call a continuous phase frequency shift, and this keeps the bandwidth much smaller. So this technique also helps with the signal width. So I thought that was interesting. So here's the basic encoder. What that thing's doing here is the low pass. So here's the data signal coming in from the controller, that series of bits. Here's the Gaussian low pass filter. They take the I, or in phase signal, and Q. This is the Q, or 90 degrees out of phase. So an I and Q signal of your input signal, and the I and Q of a local oscillator, and they mix those and sum it, and that's what goes out on the air.
Right.
Yes, sir.
So let me add two things. GMSK is extremely popular. The world standard outside the United States is GSM, cell phones GSM, that uses GMSK, so that's a proven technology. But number two, more importantly, GMSK is compatible with traditional FM radios, which means you can use Class C amplifiers, it can be nonlinear amplifiers, unlike some of the other modes where you need like a single sideband that has to be linear. That's very important.
We'll show that in a minute with the hotspots coming up.
Yeah.
So here's kind of, so this is one of ICOM's little ads that say, hey, if you, anybody tries to get T-Mark as our repeater frequency management group, and if you try to get a repeater pair, an FM repeater pair around here, nearly impossible. And the ICOM will explain, well, you can stick a D-Star signal between the channels. In fact, you can get two D-Star channels, D-Star signal in one space you would allocate for a single FM. So this is their, reason why D-Star is better than analog FM. Better. And so here's a spectrum, and I'm not sure how long. This is mine is 50 dB here, and you can see this one's at 5, 10, 15, 20-ish. And at 50 dB here, it might be 5, 10. So you can see it is really narrower.
What's the signal on the top?
Oh, that's an analog FM signal, and that's a D-Star signal.
Same scale.
Same scale.
Hard to read, yeah.
Yeah, sorry, 5 and 5.
Okay.
I'll make sure we post this deck and you can. Okay, so that's what D-Star is. So what can I do with it? So for over here, it obviously will work simplex. I can have one D-Star radio talking to another D-Star. In this picture, where's the ambi chip?
Inside the HD?
And inside each radio, right? Each radio's, and so each radio is doing the analog to digital conversion. Okay. You can also get a repeater set up. There's two guys talking, people talking over a repeater. Again, the chip is in the HTs, and this thing is just relaying the packets back and forth. Now the magic comes. What happens if I set up, now that I've already, since the radio is putting out digital frames, what happens if I set up a network system that will move these frames around? So I could send these frames over to San Francisco and London. So now, I've got essentially tied 1, 2, 3 peeps for it. How many conversations can I have at once on this setup? How many do you think? 1. What happens is when this guy talks, everyone hears what this guy says. Likewise, this guy can talk over here, and everyone hears what he says. So it's a big honking repeater. Yes, sir.
Does the internet connection just look like another person with a radio, or is it a special kind of user? Using that kind of metaphor. In other words,
yeah, let's hold that question until we talk about routing. Maybe that will come up, we'll answer it then.
Okay.
We'll talk about routing signals. Yes, sir.
Okay, so how is this different from Echolink?
Very good, that's a great analogy. This part is very similar, except instead of like radios, I've got a laptop, right? I've got it sitting in front of my laptop, and I turn on my Echolink, and I hook into one of those stations. And so yes, the Echolink is a very good analogy to this, except there's no RF involved, right? It's all computers. Well, I'm sorry, that's not true, because you can link a repeater to an Echolink, you're right.
Right. So you can use an analog FM radio to
Talk to a repeater that's been hooked into Echolink, you're right.
Been hooked into, and so the codec function is done at the repeater side as opposed to the HT.
Good point, yes.
Yeah.
Bruce?
Yes.
So, if two people had their HTs,
Yeah.
like in the second one, the local repeater situation,
Uh-huh.
and they both keyed up on 146, 355 transmit, 955 receive, so our repeater would hear it. Would
Yeah.
it actually pass that,
Yes.
through? And then the other guy would hear it, and it would probably be code?
Maybe.
Yes, it might work. I don't know what sort of audio processing our thing does. That's be an interesting test to try that.
Yeah, okay.
That would be interesting, yeah. We use it, and we'll talk about it coming up. A hotspot uses a regular analog FM transmitter and passes the data through it. So it's be an interesting test. That's a good question. All right, any questions? Keep going. Okay, so this is ICOM's kind of all my different applications. So, application one we talked about was a digital voice kind of repeater. Another application I can send my data messages, using what they call within digital voice. Remember, there's that data channel, so I can send low-speed data through that thing. There's something called DRAT. You can hook up your computer and do sort of messaging, instant messaging through it. Application 3 is GPS tracking, because some of these D-Star radios have GPS receivers, and you saw in the protocol, there's space to insert latitude and longitude GPS coordinates, so that can be used. And then application 4 and 5 use the DD modes. These are all DD modes, DD. This is DD, we remember that, and that was the high-speed digital data mode. And something like they have a radio called an ID1, which not only does voice, but it has an Ethernet jack on it. So I can plug in my computer to my ID1, and I can go on to browse the internet over this radio link. It's interesting. This is also what they use for the Marine Corps Marathon. The Med team uses this approach. And interesting thing, they make sure they turn off. They can only go to certain sites. They have to make sure the browser, most browsers encrypt all the time, and so you can't be in encrypted mode, because then you're sending encrypted data over amateur radio frequencies. So it's kind of interesting with that. IP cameras too. Again, you can plug an IP camera into this thing. Okay, so these are these modes. So there's another kind of neat. So here's the, with generic APRS kind of stuff, you can show up on a map, right? You'll transmit your APRS. If you're transmitting on 144.390, that's the APRS frequency. You'll end up on a map. With D-Star, you can be picked up by any D-Star repeater, any place at all. And there are bridges out there that will pick up the data off the D-Star, from the D-Star system, and plot you on a map. And so you can tell the difference in this as a little D-Star there. You can see that. So that's the, and you do have to turn that on in your radio, and you do have a GPS receiver. So these gateways are getting very popular. This one was the 388, now 75% are up to date, and the D-Star network's got a lot of monitoring and metrics, and you get a lot of reporting there. We'll see some more of that in a minute. But here's our site down here, KV3B. Green check mark means you're up to date and you're syncing, and if anything else means there's a little problem. And if you go to this page, you can see there's a whole other section down below with the gateways that are in trouble or out of date or having trouble staying synced up. Okay, so there's another cool thing this does now. Remember that first picture where we were tied to the internet and it said one conversation. So obviously that can get a little awkward, right? So what happens, I can logically divide the network up into sections, or let's call them, and they set up these things called reflectors. So now on this picture, how many conversations can I have at once? 3, right. So I could have the Frederick and Germantown guys could all be chatting together. The guys in Italy can be talking in Italian over here, and then this reflector can be a more worldwide one. So this kind of neat thing that I can sort of partition these the reflector that my repeater gateway is tied to. All right, so that's kind of neat. And so these reflectors are growing. There's, you see that, I told you I use a small font. There's 69 down here right now. They're growing quickly. There's actually one RF20, you'll see reflector 25 Bravo is a National Capital Regional area, so we have one for this area. That typically all are the Frederick repeater, the Mount Airy one, and ours typically will fall to as defaults to be hooked up to. There's also now other groups, because that specification, the gateway specification is published, there are other reflectors popping up. There's an IDRC one, there's an X Plus one, and we were currently adding software to our gateway to be able to hook to these other reflectors. Yes, sir.
Wait, so if I want to talk to a reflector, it's like I call a reflector?
Yes.
Was I right in both comparisons? Instead of calling Fred, I would call a reflector.
Yeah, you don't have to call a reflector, and that's why people like you, the gateway itself hooks up to a reflector, and then we'll go over commands. You can send the gateway commands to switch it to different reflectors.
I think you're right. I better wait for Rohde.
Okay.
Yeah.
All right, so this is kind of neat. Lots of, so in the area, so again, if you're having a wide area drill or SET, it's a nice, you can set one up. One of these reflectors is a digital one. If you want to use the digital mode a lot, so there's no talking on it, but there's a lot of signals going on because everyone's just putting stuff in the digital part of the signal. And so there's great metrics on this thing. You know, they're saying the growth, you know, the repeated number of repeaters and gateways is increasing, number of users are just taking off. So lots of still very interest, lots of interest. And here's the DCS and XREF systems are new set kinds of reflectors that are out there that are growing. Again, great metrics out there. You can last 24 hours, you know, what's going on, last 24 hours, we were only here for 5 minutes. Last 5 minutes, worldwide D-Star users, you know, you can watch that thing, sample, you know, if we were on here. So again, lots of good metrics out there. It does a lot of collecting statistics. All right, so let's spend a few minutes and talk about the repeater gateway system. That's sort of the secret sauce of making this all work. Alex always mentions OV1s. So this is the OV1 from ICOM. This was in their original, their new concept sheet. Essentially, and this was their 1, 2, 3, 4, 5, 6. These are the 6 features they were trying to get at the D-Star system. They want digitally modulated voice and data communications, high-speed data access. They want to be able to provide an IP connection that I could transmit through. Repeaters allow the repeaters to handle both digital and analog voice. System operates on multi-site and backbone connection. So in their concept, they have these repeaters, and they do allow for an alternate backbone linkage, alternate other than the internet. We'll see that in a minute. So this is their concept. So what this looks like, this is their ICOM repeater stack. There's essentially a controller here, and then they have a 1.2 gigahertz data module, or 1.2 gigahertz voice module, a 2-meter voice module, and a 440 voice module. They assign a convention of A modules are the 1.2 gigahertz, B modules are the 440, and the C module is the 2-meter. And that's just the convention gets set. You'll see why that's important in a minute. And then the controller here is tied to a computer and off to the internet. As far as the alternate, they do have an option where you can add this 10 gigahertz microwave link. So if the network is down, you can go out this microwave link. So it'd be interesting to find out, Dave, if we could tie this to this. Oh, here you go. Sorry. Tie this to our backbone at some point. I don't know. We'll have to see. I think it's an option. So this is what our mark controller looks like. We've got the controller, and we've got one of the RF decks, the 440 deck right now. And we did take I think Dick was the sponsor for some of this, but essentially we took advantage of a deal from ICOM where they'll give us this equipment. This is the equipment they gave us for free, provided we put up the $3,000 or something. So I think we put up $3,000. They gave us this equipment for free, and then we had to sign up at least 10 users, and we were able to do that, and they gave us the $3,000 back. If you open up one of those, the RF deck, surprisingly, there are just 2 ICOM radios in there. So that's kind of interesting. These radios operate at the same time, right? One's receiving, one's transmitting, and we were getting some descents at the time. So we did go ahead and there were some recommendations out there about replacing this silly connector to the bulkhead with a better shielded, more robust cable. So we did that. We used shielded controller cables between the deck and the controller. So we did a lot to sort of clean up the thing. We were surprised a little disappointed, I think, with some of the engineering on this thing. If you pop open the controller, not much excitement going on. There's a block diagram here. Essentially what the controller is doing, it's taking the data coming off, here's the gateway server, Ethernet controller, and it's routing it to the different band modules. And this is not drawn right there. It could be multiple modules here. And then this is the alternate microwave link. So essentially it's switching. You could send it out the microwave link or over to the computer.
But the microwave link could be just another Ethernet.
That's not clear. It's not clear what, we don't know enough about, I don't know enough about that one yet. And if we could dump it over the backbone, I don't know. That's a question.
Where I was going.
So what our Germantown site looks like, we're hooked into our host infrastructure behind their firewall. We have a Linksys WRT54G router running the DDRT firmware. It's hooked to here's our gateway. We've got a 1RU computer in there with mirror drives running CentOS, Linux CentOS. And there it's hooked to that controller you saw and the 440 RF module. So that setup is the Germantown, that's that node then, one of these nodes in those networks. And so again, here's this picture, this is us down here. You can actually click on this node, that entry, and you'll see this is all our information. So you can see that we're registered with the root, all the gateways are registered with the root server. Here's the last synchronization was 3 minutes ago, that does it every 5 minutes. They keep track of our software and we'll update it if needed. The checksums are checked to make sure that, when there's no, someone doesn't get in there and do some spyware or something. So it's pretty nice, and we report which systems are running, and they can do updates. And they check make sure our D+ page or D+ status page is okay, I'll show you that in a minute, and our registration page is okay. Here's our our D+ dashboard. When this is sort of boring right now because I've got the gateway up, the RF deck is down because the antenna is not connected because we have to move the antenna. That's one of Terry's projects here. So it's basically, here's the different modules. I don't know why the D+ guys put D and E here. There's no, maybe that's future expansion. Normally you'll only see, on our thing, only B, and you'll see what different reflectors it's tied to. Or you can also tie to another gateway. They'll come up in a minute. The hotspots will show up here. When we have the hotspot fired up, it shows up here. And here's some of the last users coming through the system. And we were a little puzzled how this happened, given that there's no RF deck hooked up. It turns out he was using a DVAP or a dongle, and we'll talk about that in a minute. But here's our URLs, and get to that site. I'm going fast. Any questions on that section? It was okay? All right, so let's talk a little about the equipment a little bit. So I touched on a little bit the ID1. It operates FM digital voice and digital, and that should be a DD, sorry. Digital voice and DD. The high-speed data connections is Ethernet compatible. So there's an Ethernet jack out the back. And I mentioned the medical team uses this during the Marine Corps Marathon. They put an ID1 in each of the med centers that are off the hill there. And essentially allows them to, and then they hook a little Linksys bridge into it and plug the computer in, and they can use the medical reporting is done but through a browser interface to a system, so that's how they get to the system. And then there's a bunch of mobile radios that are out there now, 220s, 880s. I think the 880s is popular, the 220s was pretty popular too out there. Some of them have GPS receivers, some do touch screens, some get pretty fancy. And they all can be used for regular FM too. They'll do regular FM, so any of the characteristics of typical dual band, 2 meter 440, they can do regular digital voice or they can do the regular FM. And then there's the plethora of high handhelds too are available. Same kind of thing. They'll do regular FM or digital voice. Some of them have the APS receivers built into the microphone. I think they discontinued that one, right? Now what's interesting now, here's some interesting ones now. Here's I mentioned, remember initially the only D-Star stuff was produced by ICOM. Well, here's Internet Labs made available this thing called a DV dongle, digital voice dongle. And essentially it allows you put this a USB, you stick it into your computer, and allows you to get on and talk with D-Star. And so what it's doing, so remember our chain here, here's our guy talking, And somehow my voice has got to get encoded by an ambi chip before it goes out on the network. So what these guys did was they looked at the gateway protocol, not the on-air protocol, but the gateway protocol, and figured out how to create that same data stream. And all I needed to do was encode the voice, and now I can get on the D-Star network. I can connect to reflectors or repeaters, and I can talk without a radio.
So that ambi chip is inside the DV dongle?
Yes. The next thing they did, they got even clever, is that they did a digital voice access point. You hear people call it DVAP. And what this is like a mini hotspot or a minute radio, right? It's produced by Internet Labs. It includes a little 10 milliwatt 2-meter transceiver. I'm not sure whether they have a 441 mount or not. But I can use my HT and I can talk to this thing, and then this thing will connect me to the internet. So what does that look like? So here's my HT. I can be walking around the house and using my HT. And I'll talk 2 meters to here, this thing. So here they've used the on-air protocol spec and figured out what to do, and so they set that up. And so basically converting the on-air protocol spec to the gateway protocol spec. Where do you think the ambi chips are in this picture?
In the red box.
Just in the radio, right? This is just taking the payload from here and taking it into, essentially this is a protocol converter. This is on-air, the air protocol converting it to a gateway protocol. All right, but this allows people to walk around their house, use their HT if they're not near they can't reach it, they're not in range of a full, a gateway hotspot, they can use this thing.
Bruce?
Yes.
Do that sentence again with the word protocol in it twice, but say it differently, because I kind of missed it. The on-air protocol to the...
Here, this is the on-air protocol.
Yeah.
And this is the gateway protocol. So I can take the payloads, the payloads that are coming out of this thing, and I just need to put them into this protocol.
I got it.
So this is the on-air. So before, the previous chip, the previous thing just had to do the gateway protocols. So that then they said, okay, well, let me tackle the on-air protocol. So now I got a thing that will connect the two.
I have a question.
Sure.
Do you know if anybody has cobbled together some kind of an adapter for an FM repeater, so using an analog FM radio, and the back end of that repeater system talks D-Star over this internet cloud?
You mean the basic?
In other words, both the codec chip, the ambi chip.
Like the Echolink example you mentioned.
Yeah.
Yeah, I don't know if anyone's done that. That's an interesting project, right? It's sort of a D-Star gateway, kind of, a D-Star audio gateway or something. Right?
The D-Star gateway.
So then so the other thing came out, the other configuration too, we've got these, what we call hotspots, and we talk about analog radios. This question about the repeater is a good one. Basically, we can take an old-fashioned analog radio, and as long as it's got a 9600 output out of the detector that doesn't go through any audio processing, we can hook a GMSK modem to it, and hook that to a computer, and with this, that's called a hotspot, and now basically I can take an HT, and I can talk, get into the network. And then we've been able to replace all the software running on a laptop with a Raspberry Pi box. And so in fact, we did that for our club, has a hotspot here. So here's the old-fashioned radio that Terry found on eBay, analog radio. It does have the data connection comes out the back, so you can get to the detector and the varactor without having to go through all the audio processing. We hooked the modem into that, and here's the Raspberry Pi computer, which is tied to the internet. So this gives you a little higher power hotspot, because you get about 25, 30 watts here.
Bruce?
Yes.
So, the hotspot is sort of the same thing as what's in the DV dongle, but just operates at a higher power?
Yeah, it's similar to the DVAP, this DVAP.
Sorry, yeah, right.
Yes, exactly.
Okay.
But when I key up with my D-Star HT, I'm talking to an analog Motorola radio, right?
Well, and that's probably all that this thing is too, right? It's
Yeah, I just...
Yes.
Yes.
Oh, on this, if you're working with our hotspot, for example, it's an old, just a basic FM thing. That's why your question about the repeater would be interesting, yes. All right, so those are... All right, just as a note, if you guys are setting up dongles, DVAPs, or hotspots, you'll need to punch hole at your house. You'll need to punch some holes in your firewall because the D-Star data stream, and who was asking me about the UDP packets, have to come in on port, a couple ports here that you'll have to open up so they can stream into you. Okay, so just a question, we talked a little bit on this hardware, where we talked, here's the stack, the ICOM stack that's typically at the large repeater sites. We talked about the mobiles and the HTs, and we touched on the dongle, the DVAP, and the GMSK modems that allowed you to make these hotspots. Okay, moving the time, you guys all right?
Yeah.
Okay. User registration, let's talk about that for a minute. Okay, so if I have my D-Star radio and I just want to talk to simplex someone, don't need to be registered, no problem. If I want to just use the repeater, talk to the two guys, and you talk to the repeater, don't need to be registered. If, however, I want to go out and use the network, then I got to be registered. And there's two reasons for this. One is for the routing. The other reason is, remember that the protocol, the gateway, this is all published out there. Everyone's out there. The IP address of the gateways are some available. So theoretically, some unscrupulous person could sit there, and if they generated that appropriate frame and message, and they sent it into the network to when they would get on the air, right? Their messages and talks would come out the repeater someplace. So that's another reason we need to protect this network. So all pack that has some of the information, the header, the D-Star network looks up and sees if you're registered and allowed to send packets to this network. Yes, sir.
So let's say that I'm registered.
Yep.
And somebody, sets it up so that they're put my call sign in their packet header.
That's a problem.
Okay.
We haven't, luckily with the sophisticated hackers don't think this is of any value yet, but you're right, there's a lot of spoofing that could probably be easily done, and at some point maybe we've got to get more sophisticated about it.
Okay.
Real, yeah. So as far as registration, we've got a nice 7-page document listing 12 simple steps to get registered. Is everyone registered here on our gateway? You can register even though you're not a D-Star user? Yeah, good. Essentially, you go to the site, you submit a registration request. You should probably send an email to W3SWJ to poke him, because every now and then he forgets to check the site, and a couple of registrations are there. And basically what the system administrator needs to do, they have to verify you have an active FCC license and that you're not already registered on another gateway. You only need to be registered once in this worldwide gateway system. All the registrations are replicated all over the world, so that's why you can talk to any repeater any place, because that's part of it. You saw that synchronization going on. That's part of what that synchronization does. So once that's done, the system administrator will notify the registration is complete, and then you log back in and you add your devices in there. And this is what magically assigns you a unique IP address in the network. So what does our registration page look like? If you go to here, you hit, probably don't have an ID, you register. So if everyone's done this, I'm going to go faster to this. And everyone's done this. You fill in your call sign, your name, email, and you set up your password, and you agree that you'll abide by all rules. And then you hit enter, and then you wait then you send Bruce W3SWJ an email, and he gets checked, does his checks and okays you, and then you log back in, and you add in fact, this is Fred's, it looks like. You add your DV dongle or your HT or whatever, and you can see you get assigned an IP address from here. I told you the font was small.
Where do you do the address translation?
This, what do you mean address translation?
Well, those aren't IP addresses on the internet.
No, there's a separate, this is a whole.
You do BGP.
Right, these are the gateways talk to each other, not using these IP addresses. But they're used internally within the network to route.
You use the gateway address.
Right.
It's a 10 series.
Okay, so let's talk about the 4 call signs.
Wait, could you just go back one quick question?
Yep.
So those IP addresses are only used for things talking to our gateway?
The things
Sort of like if you look at it, like the gateway is sort of like your home Wi-Fi router, and everybody on your inside of the house has like a 192
Right.
10 dot address.
Right, except that your home Wi-Fi router sort of extends to the whole deep, it sort of sits on top of the internet addressing. They keep this addressing, so this address is associated with our router, our KD3B router.
Okay.
And when you talk to someone who want to do call sign routing, you'll get their address, their special internal address associated with their router. And that's it, but they'll route that over on top of the big I internet routing. So this is sort of a, it's a layer on top of the, because you're right, these addresses do not go out on the big internet.
Those are locally nested.
Well, the
Yeah,
text.
they're inside, yeah, they're inside the payload of those frames. They're inside the payload of those frames.
Your comparison with home router is.
That's a good one, yes. All right, so let's talk about the 4 call signs. So it's a little awkward here. My call is pretty obvious, right? It's my call. You'll set that up. Typically, you put that in your radio. You won't change it. It's pretty static. Your call, like if I'm talking to you, it's your call. So there's a little confusion there. That's who you want to talk to. And then there's a RPT1 call sign field that you need to fill in. And that's typically the call sign of the local repeater. And there's an RPT2 call sign, the sign of the gateway you want to go through. And so if I'm just doing simple default for your call CQ, and I can just talk to simplex anybody, nothing's crazy there. There are some magical things in some of these call signs. They're normally 7 characters long. There's a magical 8, this is something new. You can put a slash and have 4 characters there as additional information that gets sent. There's an 8th character that's used, part of a call sign, and that's the port of a D-star repeater. Remember those ports, A, B, C, and G. So the 8th character, and I'll show you an example of this. So remember, A was the 1.2 megahertz, B is the 440, C, and G is the gateway computer. And of course, if you only put the gateway call sign in the RPT2C field, G's would only be in that field. And I've got some examples, don't worry. Okay, so here's a ID80 programming. Question comes up, you can put all this programming from the console of your radio, right? But it's somewhat painful, and we've all seen those things. And you might learn how to do it the first day, but then you're out in the field 3 weeks later. And so this RT Systems that does these programming software for the radios is great. It's essentially presented as a spreadsheet. And so then you can cut and paste rows, you can export it, import it. It's pretty slick. So I would recommend doing that. So here's a setup to try to talk to. So here's, so my call sign is programmed in another spot in the radio because it really doesn't change independent of the frequency or the channel you're on. So notice this is all the same repeater. So there's 11 entries here just to work with KB3B. But here's the generic one you would use to basically talk on the repeater and go out the gateway. So here's your call sign CQ. Here's the repeater 1. Here's the magic 7 characters, and this B is in the 8th position. And then the G, here's the gateway. So this says talk on the repeater and also send it out the gateway. There's some fun things you can do. Remember we talked about reflectors. You can link and unlink to the reflectors. If I wanted to link to reflector 25 Bravo, which are Washington Metropolitan, I would change my thing to channel 5 and key up for a minute, and it would send out your call sign reflector 25B and L in the 8th character to say link. And so the system would link to the reflector 25 Bravo. If I got bored there and I wanted to unlink it, I could send a U in this field, but again, it's got to be in position 8. So you key up for a minute, and it would send unlink, and the gateway will come back and say unlinked. You'll hear it say unlinked, and then you can connect it to 1 Charlie, which is the worldwide reflector. The other thing you might, if you also listen to, on some of these reflectors there are nets, and we've got software set up on the gateway that will automatically switch it to the different reflectors to pick up nets. Stu W3ICF is always sending me here, the schedule says you should switch to this net on this time. So there's a schedule that runs on there. The thing will automatically link to different reflectors to pick up the networks. And so you'll hear it do that. And on those nets, you'll hear them say quick, the way we do check-ins is just quick key. What that means is, on our thing, we check in, right? We say check in, and we say, our call sign, our name. With the D-Star nets to check in, and they use the quick key method, all you have to do is just push the button, push talk on your mic for 1 second or 2 seconds, and all that header information, which probably has your call sign and name in it, goes to the net controller, and so he gets a list. He typically uses like a DV dongle because it gives a nice report, and he's got a whole list of all the check-ins. So without saying anything, everyone checks in. So it's kind of interesting if you've ever listened to a D-Star net. Okay, so we'll come back to that in a second. Okay, so remember we talked about the reflectors. Remember, so that made sense. So there's the reflector. I forgot to go to this one. So here's the reflectors again. And does that make sense about how you would link and unlink to it? Other things you can do is echo. I'm going to come out to talk about this in a minute. On our, yes, sir.
So there's the problem that if 13 people all push the button at the same time, only one conversation can be heard, yeah?
it's just, in that sense, it's just like analog. You basically step on each other, and so maybe no one got hurt. You scrambled everybody's. So if everyone transmits at once, I guess if they're on different repeater, I guess if they're all on the same repeater, it's going to get jammed up. It's possible if they're all on different repeaters, because of internet delays, someone's packet may get there first. But in the sense of there's no time division, multiplexing here or anything. If you have two people key up at the same time, you step on each other. Now, if you're in the middle of talking and someone can step on you, and I think that's another reason sometimes you'll hear, sometimes will be perfectly clear, and then they'll go into R2D2.
Is it stepping in the analog sense, or is it more like you have collision on Ethernet?
It's stepping in the, it's in the RF is when you're stepping on each other. Yes, sir.
Maybe this is asking the same question, but if you're functioning on a reflector, can somebody else be on a different reflector at the same time on the same repeater, or it's one reflector at once?
Yeah, so we'll talk about that in right. It's good, excellent question. Right now for reflector, and reflector is new. This is not ICOM's original intent. So reflectors right now are tied to a repeater. A repeater connects to a reflector. It can only be connected to one reflector at a time. And so that's why they provide that link and unlink. So our gateway is set up to allow users, you don't have to, but we allow users to send through those D+ commands to link and unlink the different reflectors if you want to do that. So that's a downside. Well, the reflectors are nice because it makes it really easy to, you just, as long as you get to the reflector, as long as you get to your repeater, you get out there. It makes the routing much simpler. So it's a default way of doing routing.
But if you switch to a reflector, you can essentially have multiple users just on that one reflector, though.
Exactly. So this reflector 1C, this is the worldwide one. This guy in Alexandria can be talking to a guy in Virginia, in Loudon, London. Sorry. Right. It's a worldwide aggregation. Yes. That's right.
I'm sorry, my brain just derailed. So is there a way that you can, from your radio, key up, and our repeater will tell you where it is linked to?
All right.
So
yes.
That's what the I one was?
That's what, yeah, exactly. Okay. Very good. Exactly right. So you can do an I command. Okay. And they announce, they've recorded messages up there that you can announce. You can get fancy. I was playing around with the record. It can record and play back, I think, 9 voice tracks. You can sit there and record something and play it back, or in addition to the echo. Yes, sir.
You've got, instead of pushing record or unlink, you've got them as separate channels. So you dial up a channel and key up, and it does what that channel is programmed to do, right?
Yes. How else would you get that command in there?
Well, I don't know, because
Right.
I never had one of the radios, but
Okay,
I
yes.
haven't seen that outside of some land mobile.
Right. So here's the name I have in the field, right? So I can sort of see what this channel does.
Yeah.
And so I have this case. You typically put the main repeater here, and then down, I didn't include it. Down here would be another set of channels for another repeater. All right, so let's talk about let's talk about routing. This is supposed to be the fun part. So gateway system. So we talk about essentially the user's call sign with a discrete IP number within the gateway system, right? Because you're exactly right, it does not go out. And that happens at that user registration time. So you can register more than one device. People have a dongle, an HT, and a mobile, so you would have to put all 3 devices in there. Okay, so sign, if you notice, okay. So typically, you'll never see those IP. So once you get registered, you never have to put an IP address in there. It's all done with call signs. But just behind the scenes, it's using IP addresses. So the system, tracks each user call sign last location. So if I, get on here in Germantown and talk to radio, and then I get on a jet and fly over to London and talk over there, the system will remember I am now at a London repeater. So it remembers the last location you were in the system. So if I wanted, when we start talking about call sign routing, I could say call WA3-J, and it will route someone's from, Vic was trying to call me, it would route over to London. So that's pretty neat, so we'll show that.
And that's independent of reflector.
Yes, good point, very good point. So let's talk about 2 routing methods. So remember, ICOM started with this, that was this plus. The reflectors were something that was added on after the ICOM system came out because the spec was published. Okay, so 2 routing methods, site routing. So if you decide, I want to talk to someone in Mount Airy, I can look up and talk directly to the Mount Airy gateway, and it will just broadcast, the Mount Airy will just broadcast. Or if I want to talk to a certain person, this is user routing, I would say, who's the user ID you want to talk to, and the system will find the right gateway for me. So red, let's say red is the site routing. So I would sit there, so this case is our London. So I would sit here and program my radios, I want to talk to the London repeater. And I can sit here and start talking, and my voice would come out in the London repeater. Now the problem is, and we'll talk about that, someone over here could start talking, am I going to hear them?
Yeah.
No. Oh. Unless they set up their radio to say, I want to send my voice back over to the Germantown repeater. All right, so this is the downside of this is not a reflector, this is site to site.
So you can't lurk on the London repeater and listen for a while before you join in. It's not quite the same.
Right. You have to sort of to call over there and announce, and it's kind of interesting. That is a problem.
So how do you do it without?
Well, I'm sorry. The gateway will make wait on your records until the. It's not like the packet arriving will not key the transmitter if it's not already keyed. That's a good question. I need to go check that. I don't think it will turn on if this thing's already transmitting because this guy's talking. An arriving packet will not turn on the transmitter, not override it. I believe that's the case. That's a good question. I should go check these things. Okay, user routing. So user routing, this is kind of cool thing now. I'm saying I could sit over here and put VIX, WB2U's thing in my your call field, in my radio, and the system would go into the system, and the system would look up, find where was WBICF's last time he was on a repeater, and it will find it and send it out. Maybe he was in Rome, I guess. It will send it out to the Rome repeater, and Vic will hear me. Or who's ever over there. Now, if he pushes talk, will I hear him?
Hope so.
No. He has to program his radio to come back to me. Now, it turns out, we'll get to that, there's a special button they're starting to put on the radios, that if I push it quickly enough, it will capture that field from the header, put it in there, and allow me to talk back. We'll get there. So just the concept's here.
Does he hear you?
Yes.
Oh, but he has to push the button to send.
On his radio to say,
connection
oh,
back.
something's not right. To
Right.
set up the connection to come back. Okay, so here's a little example. This is site routing. So he's given this information here. We've got this information. And here's how I program my radio. My call, again, stays the same. I set the repeater 1 to W2KPQ. This guy's held in New York. Here's the B module. So what band is that? B. 440, right?
440.
Right, very good. And then here's the G. I want to go out the gateway. And I want to call this repeater, the VK8 in Darwin, Australia. All right, so this is something new too. I didn't know that. You put the slash in the front. So what happens? My call will be routed out to my local repeater over to the Darwin, Australia repeater, and my voice would come out in Australia. That's pretty cool. And anybody in Australia could hear you.
Right, and everybody on that repeater in Australia could hear you, but if somebody wanted to talk to you, they'd have to hit the button real fast to establish the route.
Right, and then also on part of the text message that you'll see on a lot of the radios have screens, and you'll see the person's call signs. You can write down or whatever, or they sometimes have their location. Yes, sir.
One question, a little bit more general than this. You said there's this D-Star network out there, you put it as kind of the cloud. How is that maintained? Is it distributed across all the systems, or is there some central servers that maintain?
There's one, so is this whole, did I have it in here? I lost it. Did I go right? There's it. Yeah, so this is all the repeaters, and they do all talk to each other. There is one, you see this, there's a US route here that we all sort of synchronize to for, I think it's time and something else. I know. So there's one sort of computer that we sort of register with,
Yeah,
but after that it's a peer.
Yeah, well, I'm asking who maintains the registration information? Where the last caller was, is it distributed across all the gateways?
Yes, yes.
Or there are
That's
separate
this
servers?
that's this replication that goes on.
Okay.
So yes, all nodes know where everyone is.
So it's like DNS servers.
Yes, cluster, like a cluster
Yeah.
almost. Okay, so we did the site routing. Let's talk, so here's user.
Can I just ask a question? So if you did that and you keyed up on the Darwin Australia repeater and you said, you know, CQ whatever.
Right.
So your call sign's gonna come out. So now somebody has to sit there and go through all kinds of crazy programming on their radio if they don't have that magic button to be able to talk back to you?
Yeah, so you would need to say, here's my repeater name, or so, or they could, well, they could put your call sign in there and they could do.
But I mean, you have
use
to
it.
sit there and do a bunch of fiddling
Yes.
around. So you'd have to be sitting there for a while to make sure somebody was gonna answer you. You're giving
Be
them enough
patient,
time
yes.
to do this.
But I think most of the radios all have that button now.
Okay.
I think pretty sure that's pretty widespread. Okay, so here's a user routing then. So here's my user, my information I'm starting with. Here's I'm going to program my radio and I'm going to say I want to talk to N5MIJ. So he keys his radio up and says hello and calls him. And so what the system's going to do is find the last RF module N5MIJ used anywhere in the world and put a code. That's pretty cool, right? That's neat. So that's user routing. All right, so here's just another pictorial again, just to drive the point home. So here's W7JRL, that's in my call, right? I want to call N9J8 in your call. I talk to my local, and I'm not sure why that module's missing there, unless this is 1.2 gigahertz, then you don't need it, okay. And here's, I want to talk out my gateway, all right, so that's all correct. And he goes over here and he talks to him. Okay, this is another way to look at that. We talked about how it knows, again, you go to the dstarusers.org, there's a display there, and you can just watch people checking in. This thing just scrolls constantly. You know, here's packets, you know, I've heard this user, I've heard this user, what repeater they're coming in from, what node they're on that repeater, timestamp, so it's collecting all this data.
Do people who come in through a DV dongle show up on there?
Yes, because a DV dongle has to tie to either a reflector or a gateway. It has to get in and say whatever node they're coming into the system from.
Okay.
Notice I don't see any reflectors in this list. They're all those. And so again, there's cool stuff you got there. There's activity. You can say here the latest. This is the latest active D-Star repeaters. And you can click on, you know, right at that instant, and you click on one of those things and say, here's all the last stations that were heard. So you can just sort of manually, if you want to talk to a certain part of the country, talk to call sign, click there, and you can find out someone's call sign and give them a call. So again, there's a lot of good information there if you want to locate people quickly or talk to somebody. This is kind of a fun thing to do. If you had, unfortunately we don't have multiple modules in our stack, but you could sit in this particular repeater, the NS9RC, they have multiple modules. They have a 1.2 gigahertz and a 440. This guy can call, and one guy was on, had an ID1, he's on 1.2, but I can do a cross-band call this way. Same thing with, it's kind of interesting, on a, you can be calling, in our system is a 440, but you could be talking to someone on a 2 meter system out in the Mount Airy or one of the other ones, simply by changing that port number. Okay, so here is, so this is the comment. So we talked about repeater routing, or sort of location-based routing, and call sign routing, and those were part of the original D-Star design. The user repeater linking and reflector linking were added by this D+ software. There was, you know, this add-on. And so talk about 1 and 2 are simply more complex, and if you both, okay, if you don't get it right, you will not be able to talk, right? So you have to set it up. It's more efficient because with a reflector, I've got one conversation going on, right? If I'm talking, there's only one conversation on that one reflector. If I do the call sign routing, location routing, I'm only tying up the 2 reflectors, my reflector and the target reflector. I'm sorry, the target repeater, my repeater and the target repeater. So in that sense, it's a little more efficient. You can have more conversation, but it's a little harder to set up. So right now, we're running in reflector mode most of the time. We have not really played around with repeater routing or call sign routing. I'd like to. It'd be fun to start doing some more of that. But we typically run with the reflectors on the ladder in 19-degree weather. But I think the plan is we're trying to move the D-Star repeater is, it all started because we're trying to replace the cable to the old antenna, and we can't get to the box because it's over a 3-story atrium. So this decision was to move the antenna to an area we do have that better access to, but Terry also wants to put it up on it's on a lower roof, so he wants to put some tower sections so we're back up the same height. again. But it will be a shorter run, so it'll be good, and we'll put that a coax in, so we're hoping to get good coverage by it. And then there is a sort of a hill at the Mid-County Highway. There's a rise, so a lot of the signals have trouble getting past that Shady Grove Road lane, so that's why we're looking for people to put hotspots. So I think Tom is going to put one over in Silver Spring, and I've got one in my area. All right. Well, thank you all very much.
Well, that's it for now. Thanks so much for your time. You can find out more about the Montgomery Amateur Radio Club by visiting our website at www.markclub.org. Bye for now.